Yes, welcome back to my channel. In my channel is physics course. Yeah. In this moment, we have discussing about the wave, the properties of wave. This is come from book. That book is physics for A and S level. You can see this is what book our use from CUP, and this is about course book. Yeah. And so also we have this is about the course book. Yeah. What we'll today to discussing about wave. Yeah. Uh, Actually, in page 80 we will discuss. This is what I with student discussing before we have class physics. Then to number in uh, for workbook, yeah, that on the page 80, if you have this book, you can see, yeah, this is on page 20. Uh, let's talk about our numbers here. You can see on this question one, we have to diagram about wave, yeah, diagram one and diagram two. This is different about the amplitude. The amplitude one is small one than amplitude two. Yeah. So we have point P and Q, that point on the wave, on the transfer wave. So some question we need to discuss here. The question one is, I think about PQ, yeah. Okay, about the wavelength. Wavelength. So, in this diagram, we have that the one square, one row is 4 centimeter. Yeah, one row is 4 centimeter. That if we have point P and Q, yeah, point P and Q are 3.4 lambda. Yeah. But let's say we're talking about the lambda. Yeah. The lambda is 2 div. So we can calculate 2 div. If one div is 4 centimeter, so 2 div equals to 8 centimeter. Yeah. So that's the answer. The lambda is 8 centimeters. Okay. Question 2 is about the we need to find the velocity. We need to find the velocity. Then velocity is lambda over t. Also we have velocity also lambda times with time with frequency. But we have parameter about t. Yeah, that 7 wavelength equals to 0.10 second. So in 7 wavelength, in 7 period, we have 0.10 second, and then we get the period is 0 0.1 divided by 7. Yeah, I don't know how the whole numbers is. Yeah, we can use the calculator. But we will continue about velocity or speed of wave. That velocity is we use lambda over t. Yeah, we. I will use this for handing it, or I think cannot. Okay, we'll continue this about the wave velocity wave lambda over t. So we get the lambda equals to 8.0 centimeter and period is 0.10 divided by 7. So we get 7 times with 8 divided by 0.1 is equals to 560 in centimeter over second. Yeah, that's the velocity of wave. Okay, now the question B, question C about the frequency. Yes, correct. The frequency is 1 over t because if we know the frequency is amount of wave divided by time, and then period is time divided by amount of wave. So if we calculate, yeah, from this equation, we get frequency is 1 over t, or t of 1 over frequency. So we get the frequency 1 over t, 1 over 0.10 divided with 7, so we get 70 hertz. Yes, correct. That's the frequency of this wave. Now, the question D is compare the amplitude wave at the P and Q. So this is one diff, yeah, on the diagram 1, and this is also we have a half diff. So we get this is around 1.5 diff. But in diagram 2, this is only one diff. Yeah. So if we compare about them, yeah, we have some conclusion that P, if this is about the maximum amplitude. If you know, I think you know about this one diff equals to 4, and then a half diff equals to 2. So we adding 4 and 2, it becomes 6 here. And so maximum amplitude is 6 centimeter on diagram 1. And what about Q? Q is on the point that's 0, so Q is 0 amplitude. Okay, now about the diagram 2. The diagram 2, when P is on the stationary point, yeah, P is equal to 0 amplitude or 0 centimeter, and but Q is minimum amplitude on the deep, yeah, on the throw, so, yeah, there are negative of amplitude, yeah, negative amplitude, negative 4 centimeter. Yes, okay. So and then about the equation. So the equation, this is about the difference phase here. Calculate the phase difference between the oscilloscope of P and Q. So, different phase, this is about the Hall ratio with one wave. Hall ratio with one wave. Yes, P and Q position is in here. Yeah, you know, but the one wave is one press and one throw. So P and Q is around 3.4 of wave. Yeah. Then the different phase is equal to whole length with one wave, but times with 2 pi. And 2 pi equals to 360 degree. So we get that this is about 3 over 5 times with 2 pi, or 3 over 5 times with 360 degree. So we get 270 degree. This is the different phase. Okay, let's continue about F question. The F question is, at the time T1, the amplitude oscilloscope P is 6 centimeters, yeah, and the time T amplitude is 4 centimeter. Calculate the ratio of intensity of wave at point T1 and intensity of wave at point 2. Yes. This is about the ratio of amplitude. Why? Because we only have the parameter that different is amplitude. Yeah. Let's say we have frequency as same. Let's say we have the rate also as same. Yeah. And different is in about the amplitude. So the intensity is proportional with amplitude square. Yeah. Then if we calculate amplitude 1 divided by amplitude 2 square equals 6.4 square, or 6.4, this is meaning about 3 divided by 2. So 3 divided by 2 equals to 9.4, 9 divided by 4. Okay. Continue. Now about the other question, the question 2. Yeah, the question 2 is, yes, sorry, little bit, yeah, okay. Now question 2, yeah. I will see first again with about the question. Yeah, you can see this. Yeah. Okay. This is a diagram about the longitudinal wave. Yeah, we have point E, B, C, D, and E. E is the point. If you know, this is about the compression. B is a center of rarefaction. C and then D and then E. If we know CDE, D is the center of compression. Okay. Let me see about the some number question. Yeah, and we will to discuss it. Yeah, please let me see about this answer question. Okay, sorry. Yes. Question one is, yeah, this is the answer for the question one. Here we go. What difference between longitudinal and transverse wave? Yeah. Longitudinal. The longitudinal and transverse. This is the longitudinal. The direction of propagation wave is parallel with, yes, the propagation with parallel. So if you know about the like a sound or slinky, if you know that the propagation of the wave is parallel with the motion. Yes. Different with the transfer wave, the propagation of wave is perpendicular, going up, going down, and then the move is on the right side, but up and down. This is we say about the uh, perpendicular. Okay, so uh, other question in still E, yeah. Step difference and similarity between longitudinal and how about the similarity? The similarity is one, yeah. One of the similarity is carrying the energy. Both of this wave, longitudinal or transfer wave, this is about the carrying the energy. Yes. Okay. Continue to the question after that. The diagram is longitudinal frequency. Yes, this is the diagram there. When the frequency is 3 hertz, yeah, we get from this question here, we have frequency as 3.0 hertz. So, oh, sorry, I'm forget. The II give one example. Its type of wave. Yes, the longitudinal, the expansion of longitudinal. This is about the sound wave. Yeah, and transfer wave. This is about light. Yeah, the example of them. So, A, B, C, D, and E a point through with the water traverse. Explain what the mean by frequency. Explain why the frequency. Yeah. We know before about the frequency and period. Yeah. The frequency is total amount of wave per time. Yeah. That's the frequency. How many wave in one time? Yeah. If we have 5 wave in 1 second, yeah, that we have 5 divided by 1, yeah, it's equal to 5 hertz. Okay. That question BII, state which 2 points are one wavelength apart. Yes. This is actually the graph is, this is A is a point of compression. Yeah. This is point A, and then rarefaction on B, and then compression again. C, D, and E. This is a point of compression. This is a center of rarefaction. This is center of rarefaction. Yeah. So the wavelength is the center of compression to center of compression also. Also we said also the center of rarefaction to the center of rarefaction. that one wavelength. Yeah. So it's talking about the period. The period is time when the on the center of refraction to the center of refraction, or time between center or on the compression to center of the compression. Okay, that's the that's the meaning. The wavelength is equals to A to C. This is the wavelength. Yeah. So continue the next number. The distance between point A and B is 14 centimeters. Here, calculate speed of the wave. Okay, we know this is from A to B is 14 centimeters. Yeah, A to B 14 centimeters. Yeah, A to B, this is about a half wave. Yeah, about a half wave. A to B is a half wave. So with a half wave equals to 40 centimeter, 40 centimeter is one wave equals to 28 centimeters, right? Okay. Now the question is what the velocity is. The velocity is lambda times with frequency. Lambda is 28, frequency, then we have the frequency is 3 hertz. So calculate between 28 times with 3.0, this is equal to 84 centimeter per second. Yes, that's the velocity. So, other question on IV, determine the phase difference between the oscillation wave at the point A and B. First walk on the friction wavelength in the axis between A and B. Determine phase difference between oscillation at point A to B. Yeah. As I mentioned before, the phase difference is how ratio distance point 1 and point 2 with one wave. Yeah, with one wave. And then we see the A to B is a half wave. That's meaning it's a half of 2 pi. The phase difference is a half of 2 pi, or a half of 360 degree. How much is it? A half of 360 degree? Yes, 180 degree. That's the difference in phase. Yeah, that's the difference in phase. Yes, that's the question of IV. So, the last question is about the electromagnetic. This is about talking about effect Doppler. So, if we'll see you about this question, are you see? Yes. Yeah, you can read first. Yeah. If this is around the frequencies, yeah, and the wavelength. Okay, let's be talking. I will read it first also. Yes, listen carefully. Electromagnetic radiation has a frequency of 1.4286 times 10 to the power of 8 and 9 hertz, yeah, and wavelength 21.000 centimeter emitted by hydrogen in the laboratory. The same radiation received on the Earth from the hydrogen cloud constant galaxy has frequency 1.4194 times to the power of 9 hertz. Okay. State the part of electromagnetic spectrum in which this radiation formed. Yeah. Actually, if when I was talking with students, this is what we need to see on the table. So we skip it and continue to the next question. I explain why the two frequencies are different. Explain why, because this is about the moving of frequency. Let's say this. The same radiation received on the Earth from hydrogen fluid. Yes, this is about the motion. So this is the meaning of Doppler effect. Yeah, why the frequency is different? Because Doppler effect. This is the term about Doppler effect. If the source of sound or source of frequency that moving and moving relative with the observer, the frequency will be changed. Yes, because the motion, if the uh, object motion with the frequency source, the wavelength will be changed. Yeah. Also, the wavelength will change. It will be changed in frequency. Yes, that's the concept of Doppler effect. Okay, now the calculation about I. Yeah. Calculate the velocity the hydrogen cloud relative to the Earth. Yes. This is actually the concept of Doppler effect. That frequency observer, yeah. Velocity, this is velocity. This is not about the velocity of sound, but this is about velocity of light. We use the velocity of light equal to c speed of light is around 3 times 10 to the power of 8 meter per second here. This is actually this frequency source, yeah, and then velocity of ray again plus velocity of source. This is the parameter which will be fine. Okay, after we include this is 1.4 blah 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 something and 3 times the velocity of speed, a velocity of rate, and 1.4 times blah 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 and divided by 3 times this is velocity of rate also and times Vs. Why plus? Because the other source is emit go out, so the frequency will be decreased. So this is plus sign. Yeah. So after we calculate with my student, we get the number of the speed of source is 1.817 times 10 to the power of 6 meter second. Yes, that's the what I discussed with my student about the wave. Yeah, to number. Yeah, don't forget to see on the workbook page 80 on the workbook page 80 in this book CUP by David Seng and friends. Yeah, you can see it on the page 80. And I think I need to finish this video. Thank you for watching my video. Don't forget to see watching other my video. Don't forget to like or comments. It's okay. Also subscribe. Thank you very much. See you on the other video.